Hi. So today is a sunny day, yeah, you can see. And I am in a very peaceful and a nice place with a lot of pines. Yes, so pine forest near my house. And I want today to tell you one more topic, one more electricity topic, which is connected to capacitors and how we can use them in alternating current circuits. So that's the topic. And today I also will use my copybook, very funny copybook. I like funny copybooks, and I will use it to show you the details. So let's see. Okay, one moment. I need to find my pen. Yeah, so without, oh yeah, it's here. Yeah. So without pen it will be difficult to show you something. Yeah. Okay. So usually this notebook is not for electricity, so you can see it's with different tasks, different other kind of task, yes, connected to molecular physics. But today, yeah, we talk about capacitors in alternating current circuit. That's it. So we can consider a capacitor, yes, connected to alternating current circuit, and usually it can be painted like this. So we can have some resistor, we can have here a capacitor exactly, and here, for example, ammeter. That's it. And we remember that when we have just direct current circuit, so capacitor, how does it work? It will charge during some time, so it depends on the capacitance of the capacitor. And after this time, there will be no more current. So what is going on when we have alternating current supply? We will have, we know that voltage, yes, here is time, and for example, for voltage, we will have such a plot, yes, sinus plot, that's it. So usually when we don't have a capacitor, we have, for example, only a resistor, we should have the same plot for current. But in the case of the capacitor, it will be different. So here is time, here is current, yeah, and current will look like that. And I will explain it one more time. I will explain it, just wait a minute, that's it. So, how can we understand that? We can understand that here is a moment, a period of time during which capacitor charging, for example. And then current began to flow to another direction and capacitor discharge. So I just need to understand more during which time it discharge, and maybe here is a discharging moment. Yes, that's it. So, and here it's charging again. Yeah. So in direct current power supply, we have just such a plot, and that's it. So it's charging one time, and after it there is no current, so current is zero. Yeah. But here we have current, yes, and current repeated in a period of time. Yes, here is a period of time, during which one circle of current runs. So current runs to one way and then runs to another way, yes, and make it circle. So it's period. So we can say that we have something like average current here. So average current in this circuit. So that's nice that we at all have any current. And let's see what's going on. But we have these periods when we, for example, yes, have no this one-way current, yes. And so we don't have current, or we can say, all the time during the capacitor, yes, because it's discharging. So we can see the situation when we have current more often. That's it. That means that we have shorter periods of time and we have higher frequencies. So we have a higher frequency, yes, in comparison with this plot. That's it. So here is current, here is time, yeah. So average current will be higher here. And we have shorter time for capacitor to charge and shorter to discharge, so it's don't have enough time to discharge, really. And that's for us it's interesting and we can use it. And we can make a plot of dependency, how current depend on frequency. Yeah. So it's a linear dependency. It means that as much we have frequency, so as faster, as more dense current changing we have, more average count we will get. Yeah. For example, yeah. So usually I used to call frequency with nu. So sometimes frequency, sometimes I can forget it. That's it. So that's interesting. So to understand, yes, to make a conclusion one more time, when we have just such a circuit, yes, and we want, for example, to make a bigger current, we can make the frequency higher. That's it. That's nice. Let's see more. Let's see two interesting cases when we want, for example, to change the current. For example, we have alternating current and we want to change it to direct current. So it means alternating current, we want to change it to direct current. For that, we will need to use a diode. Yes, and we need to remember how does it work. So we can say that current flow, the exactly direction of current flow is this way, like this. So we can compare. Here is an arrow, but electrons flow to another direction. That's it, because the direction of current flow is considered as direction of flow of positive charge. Really, in conductor we have no positive charge, but we still have this arrow of direction. And we can draw a circuit. That's it. So we will have a diode. We will have we will have a resistor, for example, and first of all, that I can say that is all. First, if to paint it, so that's okay. Here we will have AC, so alternating current input, and here we will have output, which will be direct current. So and we can say that it's enough for the first time, and it is called half wave rectifier. That's it. And in this case, we will have plot like this. So we had current, we have time, and we will have only these parts of current, you see. So we will filter this. There will be no current flow into the other direction. That's nice. And here we can use a capacitor to make the current smoother, to make it looks more like direct, more like just one line. So we can put a capacitor here. And when we put capacitor here, it will goes like this. So we will have a charging time for the capacitor, yes. And that's or discharging time, that's nice, yes. We can see that. And this line, yes, make it more horizontal or more like this. It depends on the capacity of the capacitor. So here will be higher capacitor, high capacitor. And here will be low capacitor. So if you want to make the result line more horizontal, we need to use high capacitor in this case. That's it. So that's why it's easier to use one diode, but we need higher capacitor. And we can have another circuit, and it is called full wave rectifier. So I will draw it. So I make a pause. I hope it was not fatal pause, because with possibilities of my phone it can be. So full wave rectifier. So full wave rectifier, how can we consider it? Sorry, I'm a little bit stressed about this video. Okay. So it's look like this. So, and here we'll have diodes, looks like this. So here is alternating current. Here we have a resistor. And we can have just output. Yeah, just output. That's it. Yeah. So it means when the current flow to one direction, for example, it flows this way. It will flow here through this diode, here, 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 here. It's one direction. When it goes to another direction, here, 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 it goes there. Here, 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 goes here, back. That's it, and that's very important. So it means that this bridge of diodes allow current to flow in one direction, and when current flows to another direction, yes, it converts it to flow one direction. So here it will be the stable way of current. Doesn't matter is it here one direction or another one. So we will have such a plot. And that's nice for us because we have closer, yes, peaks. That's why we need a smaller capacitance for a capacitor to make this signal more horizontal. That's very interesting. That's it. So here it was full wave rectifier, and of course we talk about capacitor. So capacitor should be somewhere here. That's it. That's it. So we can talk what we can talk more. I try to remember. talked about different kind and okay. And for example, we can see an example when we have such a circuit with alternating current. Such a circuit with alternating current. Here is a capacitor and the lamp, for example, yes? And we want to understand how the lamp will work. So, for example, if we put some insulator here, it will be not problem. We just change the capacitor of the capacity, but we still have lights turn on and turn off. So just with different capacitor. That's it. If we want to make a lamp be brighter, so we just need to make more average current for it, and it can be made by making the frequency higher. That's it. And also when we, for example, wanted to change AC to a battery, it can be considered as temporary DC, yes, a direct current, or as another capacitor which is charged. So what will be in the circuits? This capacitor will discharge and the current will flow through the lamp, and it will work during the discharging time for this capacitor, or during the discharging time during the charging time of this capacitor. Yeah, that's it. It will be bright. Okay, so yeah, I hope that I can somehow merge to these videos, because it's a big problem for me without my good computer that was taken by bad people in black. I have no opportunity to make fast good videos, but I hope that today's technologies are good enough and I can make it, merge it with the help of my mobile phone. We will see. And if you like my videos, please share, and please, you can donate me different ways. You can write me at least. And so I have a very nice weather, and I told you about how to use capacitors in the IC circuits, and now I think I will drink a cup of tea and we'll go to the Minsk city center to buy something for me. Okay, thank you guys, and goodbye. If you have any question, please write me, and if I make some mistakes also, please write me and we will fix it. So goodbye.